I'm Kristin Oviedo, and this is real-life examples of absolute zero. So when we talk about absolute zero, we are talking about the coldest possible temperature. And if you're a physicist, you would say that this is the value at which entropy reaches its minimum value. But for most people, it's useful to think of absolute zero and temperature in general in the following way. So imagine two identical boxes, and imagine that each of them are filled with gas molecules. So just picture them as little bullets flying around inside the box, crashing off of each other and crashing off of the walls. So this one, you have all your little bullets that are just crashing around, and they have a lot of energy, and they're just all over the place. And then over here, imagine that you have your molecules much less energetic, and there are fewer collisions per minute or per hour or whatever you like. So if we were to then measure the temperature of the gas in these two boxes, then generally speaking, this one would be hotter and this one would be cooler. And this works not only for gases, but also for solids and liquids as well. Generally, you can think of the molecules of a substance as being more energetic and moving around and crashing more and more when they're hotter, and kind of calming down as they cool down. So this would lead you to conclude that absolute zero is the point where they all just stop moving. So within the physics world, this is known as the classical interpretation of temperature. But if you're a quantum physicist, you'll always have that ground state energy that no molecule can ever get rid of. But again, for most of us, it's useful and pretty reliable to think of it in this way. So as far as absolute zero goes, I've got a couple of examples here, one artificially created in a lab. So this record was set in 1999 for 100 picokelvins. So Kelvin is the SI unit of temperature. So again, in the lab, humans have created 100 picokelvins, close to absolute zero. But then in nature, we're gonna look for that nearness to absolute zero in space. So most of space is about 2.73 kelvins on average, but there are parts of the Boomerang Nebula that have been measured by astronomers to be around 1 Kelvin. So this is the lowest natural temperature, this is the lowest man-made temperature. But again, it's kind of like the speed of light. You can get really, really close, but we'll probably never actually get to absolute zero. I'm Kristin Oviedo, and these were real-life examples of absolute zero.